Hello, welcome to all of you in my YouTube channel. So in this video we are going to discuss about the Thevenin's theorem, which is a very important theorem in electronics. Basically what we do in this theorem is that we just convert any complex network, any complex electrical circuit to a very simplified circuit which consists of only one voltage source and one resistance in series with that. Okay, so you can clearly see here this theorem is useful when we want to know the amount of power, current or voltage drop in a particular component of the circuit. Basically, okay, if you want to find the current through any load, okay, you will be given any load, and you are asked, if you are asked to find the current through that resistor or voltage through that resistor, then in such cases you use the Thevenin's theorem. Basically, with the help of this circuit, a normally complex circuit can be simplified to a series circuit consisting of ideal voltage source and a resistance connected in series with it. I already explained this to you. What we do here, we just convert any complex network, any complex circuit to a very simplified circuit which consists of one voltage source that we call VTH, and in series with that voltage source there will be one resistance that is called RTH, and these are the two terminals. A and B are the terminals between which we place the load resistor. Okay, so this according to this theorem, entire network connected to AB is replaced by single source. Many there in this complex network there may be many sources, there may be many voltage sources, there may be many battery, 2 batteries, 3 batteries or more than that, but our intention or our aim is to convert this network in such a way that this network should consist only one voltage source and only one series resistance that is connected to that voltage source, and this is the terminal. A and B are the two terminals between which we put the load resistor. Okay, and now let us move ahead and let us discuss some procedures, how to carry out, how to convert any complex network to the Thevenin's equivalent circuit. First, what we do here is we just remove the load resistor in which we want to find the current or Thevenin's equivalent circuit. What we do, for example, if you are asked to find the current through any resistor, that resistor is regarded as the load resistor in that case, and you will remove that resistance from that component, and that is the first step. And what you do, then you just keep those terminal open as open. Okay, I will illustrate with one example, with one numerical example also, and when you remove the load resistor, just keep the terminals as open terminals. Okay, and then now you have to find the voltage, open circuit voltage, that we call as open circuit voltage, and that open circuit voltage is equal to the Thevenin's voltage, and we call that Thevenin's voltage, or we represent that Thevenin's voltage by VTH. Okay, then what we do after, then we need to find the RTH. For that, in next step we just remove the voltage sources in our circuit. Okay, determine the resistance between the open terminal with the voltage sources shorted. Basically, we short the voltage sources. It means that we remove the voltage sources. Okay, and if there is the internal resistance of those voltage sources, we do not remove that internal resistances, we just put those internal resistance, and we just remove the voltage source and we just short it. In electrical circuit we just joined by the line. Okay, this is called, and this resistance that we find is called the Thevenin's resistance. Okay, I will show. And then finally, in last step, we again put the load resistor that we remove in the first step. The resistor that we remove in the first step, that is RL, we just again return back and put that load resistance in across the terminals, and then we can find the load resistance easily. Okay, now let us illustrate this by simple example. This is a kind of the circuit. It is not so much complex, but through this we can understand so many things. This is the circuit where there are 1 2 3 or 4 resistors, and this resistor is the load resistor, because through this resistor we actually want to find the current. So we now have to convert this circuit, these 3 resistor to only one resistor, and through whole this voltage source should be replaced by another voltage source, and that voltage source is called VTH. And now if we convert this circuit to the Thevenin's equivalent circuit, we get we get the circuit like this, where there will be only one voltage source, and that is represented by VTH, and in series with this VTH there will be one resistance that is called RTH, and this is the load resistor between the two terminals A and B, and this is called Thevenin's equivalent circuit. Okay, now let us take an example through which we can actually understand how it works. Okay, we have given electrical circuit. It may little okay, it may not be clear to you, but you can know what are the values given here. Okay, if you look clearly, if you look carefully, you have seen that there is one voltage source, and that is the voltage source. The voltage of the battery is 24 volt, and its internal resistance is 1 ohm, and here is 3 ohm resistor, there is 12 ohm resistor, and there is 15 ohm resistor, and we are asked to find the current through this 15 ohm. It means that 15 ohm resistor is the load resistor. So let us move ahead. First, as we discussed in the procedure, first what we need to do, we need to remove the load resistor. First step, our very first step is that we have to remove the load resistor. It means that we have to remove this 15 ohm from here, and just keep the terminal A and B as open. Okay, like this. Here you can see clearly we have removed this resistor from here, 15 ohm, and this A and B terminals are open terminal. And now basically the potential difference between A to B or is called the open circuit voltage, because the terminals A and B are open here. As the terminal A and B are open, so we call that this this voltage, the potential difference between A and B is VOC, or open circuit voltage, or VAB, or VCD also, because the potential, the CD and AB are parallel. Okay, and the potential difference across AB will be equal to the potential difference across CD. That is why VCD will be equal to VAB, and that will be equal to VOC. VOC means open circuit voltage, and it will be equal to VCD. VCD will be equal to it will be easier for us to find the voltage across CD instead of AB. So that is why we are going to find the voltage through CD, because voltage through CD will be equal to voltage through AB. That's why the voltage through CD means voltage through this 12 ohm will be equal to I into R, and the 12 ohm resistor is represented by R2. That's why I'm writing here R2, and I means current through this this 12 ohm. Okay, now our aim is to find this current. If we able to find this current, we have already given the resistance. Okay, now for finding current, you can clearly see that there is one voltage source, that is 24 ohm, and to this 24 ohm there are 3 resistors which are in series, because this 3 ohm is connected to the 24 volt, and this again 3 ohm is connected to 12 ohm. This 12 ohm is again connected to the 1 ohm. It means that these 3 resistors are in series combination. So in series combination we can find equivalent resistance by just adding. It means that the total resistance of the circuit will be 3 plus 12 plus 1, and that will be 16. And we just find I is equal to V by R. From Ohm's law we know that I is equal to V divided by R, It means that V, in this case V is equal to 24 volt divided by resistance means 3 plus 12 plus 1. If you divide 24 divided by 16, you will get 1.5 ampere. Now you can easily find VCT or VOC. VOC is equal to I into R2. I means 1.5 and R2 means, here in this case R2 is 12 ohm. So if you multiply, you will get 18 volt, and this 18 volt is actually the VTH. VTH is also called as VOC. So that's why VTH, you have find VTH now. Now your aim is to find the RTH. Okay, for RTH, what you do, you just have to sort this voltage source. You have to remove this voltage source. You just short this component. But if there is internal resistance, you have to keep the internal resistance there. You just have to short only the voltage source. So if you do this, you will get like this. You know, we removed the 24 volt battery. We just short that component, and but we still put the 1 ohm resistance there, because 1 ohm is the internal resistance of that battery, and other components are same. There is 3 ohm and there is 12 ohm. And now basically you have to find the RTH by looking from here. When you look from this open terminals A to B, you can see that, you know, now you have to find the equivalent resistance. For finding the equivalent resistance, you have to look from this side. Okay, then you can see that there is a 12 ohm resistor, and there is another path. 3 ohm and 1 ohm are in series, and this 3 ohm and 1 ohm are in series. So that's why 3 plus 1, and 3 plus 1 means 4 ohm. This 4 ohm and 12 ohm are in parallel combination. So in parallel combination, what we can find, RTH is equal to 12 parallel 3 plus 1. It means that this is this 12 ohm. If you look from here, there is one terminal. Okay, this through this one terminal there is one resistor, and there is the common point. Through this common point there is the another path. Through that path there are two resistors, and they are again connected to the another common point. So that's why 12 parallel 3 plus 1. And when you multiply or when you solve this, the value of RTH will be found as 3 ohm. Okay, then now our we done our work, and now our circuit is converted to this circuit, where VTH, we have already found VTH is 18 volt. Okay, VTH is 18 volt. Okay, you can see here. And RTH, we have already we just found RTH, value of RTH, and that is 3 ohm. There is a VTH and there is RTH, and we again return back the load resistor that we remove in the first step. In first step, the resistance that we omitted, we have to just return back it to the same position. And now you can easily find the current, because this RTH and RL are in series combination. So current will be same through this both resistors. That's why current will be equal to V by R. V means VTH, and it will be equal to the 18 volt divided by R means this RTH and RL. They are in series combination. That's why they will be added. 3 plus 15, and that will be 18. And when you divide the current, the value of the current will be 1 ohm. So this is all about Thevenin's theorem. This is the basic idea, and you can explore more ideas about the Thevenin circuit. I hope this video may help you little bit. So thank you very much.